Thank you on behalf of Ballard for attending today. I'm Kim Leach. Today we're here to talk about the port hydrogen fuel cell deployments, equipment, and implementation examples. I'm Kim Leach. I'm the market development manager for Ballard Power Systems. I've been with Ballard for 4 years. I work in the policy and market development space, primarily in North America. I reside in Canada, centrally in Canada, but I also work on the eastern United States or across the United States when the need arises. And I work with my partner, Tim Sisian. He's the market development director at Ballard Power Systems, and he's going to talk to us today about the port concept examples for ports. And he's built a really great slide deck here at the end to put some ideas together with real life projects that are potentially possible using Ballard Power Systems products. So Ballard by the numbers. So 44 years ago, Jeffrey Ballard had an idea and started a business and a concept in research and development in hydrogen fuel cells. And today we have over 1,500 transit buses operating with Ballard fuel cell technology, 2,300 trucks, 10 rail projects in development and operational on tracks, marine 10 ships in development, and some are deployed now, and stationary 10 megawatt of stationary power products offering. And that gives us 1 gigawatt of fuel cell products delivered, over 200 million kilometers in operation, 6 production sites with a global footprint. We're excited to announce that we're going to be building another gigawatt facility in Rockwell, Texas, following a recent funding announcement from the federal government, and our other facilities in
Kim was describing our other facility in Bend, Oregon, where we're manufacturing our Buy America modules for the buses. And that constitutes what we're producing around the world, part of the over 1.6 gigawatts of capacity that we have coming online for all the different production sites that we have globally. We have over 1,100 employees, and we're deploying in bus, rail, truck, and marine, which we'll talk about later today as well. Next slide, please. This is our complete product line. We've got a comprehensive range of fuel cell products that go from medium duty all the way up to utility scale power. You can see here at the top, our FC Move product line is going out into medium duty trucks and buses, as well as construction equipment. This product line has evolved into FC Rail, which we'll talk a little bit about. These modules are from 100 to 200 kilowatt in power output, and they're being deployed in commuter rail and in freight, as well as other applications. When we get into the marine space, we look at FC Wave. This was our new product offering. It came out a couple of years ago and has really taken off. It is designed around the marine industry. It's DNV certified, the first DNV certified fuel cell module, and it's meant to be modular, 200 kilowatts per module, meant for engine bays, and we'll talk a little bit about the technical aspects of that and how it can be added together for larger systems, up to over 1 megawatt. And we even go into multi-megawatt systems where we're supplying fuel cell stacks to power generator manufacturers for utility scale of 1.5 megawatts or more. Next slide. We'll talk about FC Wave, our fuel cell power for vessel and stationary port applications. In the next slide, we can see the FC Wave in all its glory. We're very proud of this module. It's a good looking module. It's 200 kilowatts inside of a standard electrical cabinet. You can think of it as about a 2 by 4 foot footprint, about 7 feet high, with everything inside to make it safe for engine bay applications. It's essentially a container inside of a container. It's meant for a wide range of operating temperatures. It's meant for cooling systems that can be liquid to liquid. It's got its own heat exchanger, which also helps it for adding on additional power units. And it is made with our latest stack technology, the LCS. And in the next slide, you can see an incarnation of this, not only for vessel power, which we've done extensively, but also for stationary power. When you put multiple units together, you can achieve power outputs of up to 1.2 megawatts on a single skid. We call this our mega block or power gen configuration. Ballard can provide this power system, along with the cooling that's necessary for land-based systems, such as for shore power applications with air cooling on those systems. And look for more information as those systems are deployed out in the world. Some initial deployments have had very favorable results. In the next slide, we can see one of the, or a bunch of the implementations, sorry, on the marine vessel side. We've got our Norled ferry shown at the top there with one of the first liquid bunkering applications that's ever been done. Very exciting stuff there done by Lindy, really groundbreaking stuff to get hydrogen out on the water on these vessels. Kim, can you tell us about some of these other marine projects that we've got out there?
Absolutely. I'm sorry, everybody. We had grid failure, and I guess that's what we're all working towards, clean fuels implementation into the grid. So here we've got the MF Hydra, the first liquid hydrogen powered ferry in Norway, and the flagship project to power the H2 barge in Netherlands, and the Zulu River barge in France, the Electra fuel cell river barge in Germany. And exciting to see this coming forth because of the workboats and the workhorse that they really are, is the HyZ fuel cell tugboat, completed design of fuel cell battery propulsion with 5 megawatt drive, ready for the funding application. So to see something like that coming forward in development using fuel cell technology is astounding, because they really are the workhorse behind a lot of the ports today. Next slide, Suhail. So here we've got a megawatt scale stationary project that's in Portugal. The production of the electricity from green hydrogen produced at site with the power plant in Evora, Portugal. That's an example there of the Ballard's 200 kilowatt fuel cell module at the commissioning phase, and that's actually housed in precast shelters there. And we're going to talk a little bit more about stationary here. Next slide. So here's the megawatt scale stationary option. This is in Taiwan. It's 200 kilowatt FC move, introducing in DC AC and cooling, and installed in a 20-foot nice compact container system. Electricity generation and heat from hydrogen's side product from chemical process. So again, that's in Taiwan, an example of what's happening globally around the world using Ballard fuel cells. The next one is a really exciting project here in North America using Caterpillar with Microsoft at the Azure Data Center. 1.5 megawatt of fuel cell system installed with a single 40-foot ISO container. A 3-year Microsoft project in collaboration with Ballard, Caterpillar. Launched it was November of 2021. Fuel cell stacks with the balance of plant power, conditioning, and a cooling system are all included, all housed in that really nice, tight, compact area. It certainly saves space in commercial lands instead of excessive battery usage and solar or renewable that you need in other concepts and designs. And it's designed and certified stationary fuel cell power generator requirements as per the EU and CSA standards. So leading edge technology there in the ClearGen unit that you see. So the fuel cell and fuel cell power for fuel cell electric vehicles and equipment for port operations. This is a really exciting lineup that we've got here. This is really, you know, the core of Ballard, the FC Move platform, a complete product portfolio to address all commercial vehicle applications on and off road. We're going to show you some of that product line as it's been rolled out in different applications with partnership OEMs, but it starts right at the 45 kilowatt light duty forklift applications, moving through to the medium heavy duty, more the workhorses on the road, or the transit modules, and the heavy duty, looking at heavy duty, you know, if it's going to be off road or if it's in, you know, more of a class 8 type truck on the road. Next slide, please. So fuel cell electric trucks, you've got extended range and fast refueling time for off-road, non-road, and long haul. So you really want to take advantage of that increased payload that you're going to be able to utilize using fuel cell electric technology. So here's an example of some of the trucks that are on the road. That one up in the center, there's a really exciting project, especially with a lot of discussion around mining, but that one with the Anglo-American mining truck there. You've got UPS as a partner as well. It's operating on fuel cell technology. You've got an exciting Class 8 project taking place in Edmonton, Alberta as well. Next slide, please. So here you've got the Xanaf yard truck for TerraPack, 2 Ballard powered fuel cell yard trucks from capacity operating since 2022. You can see some of the fueling options there as well, the fueling integration there. Gaseous H2 fueling with power cubes delivered by trailer to site for fueling using around 180 kilogram per delivery. And then you've got the ZAC2 drayage truck, operation by Pola, 260-mile actual range, 3,096 in-service miles, plus 12,000 test track miles. So on average, using about 6.5 miles of diesel gallon equivalent. Next slide, please. So this is an exciting one. We're seeing a lot more interest in rail, especially when you've got shunter locomotives. If you've got some great opportunity to develop a shunting locomotive project, this is the one that's really moved the United States forward. Is the Sierra Rail switching locomotive. It's using Ballard FC Wave, 2 of our nice 200 kilowatt units, and built and operated at the port of West Sacramento. So again, Sierra Northern Railway is building and testing that hydrogen switcher locomotive. So here's some of the other applications. Great project taking place up in Canada in a little bit of a colder environment. So any of those ports in the colder climates, looking at developing using that FC Wave module, 200 kilowatt, the SPKC rail project with Canadian Pacific. You've also got that smaller unit in Foshan, China, the FC Velocity 100 kilowatt in passenger rail, PISA shunting locomotive, that's Central Europe, using the 85 kilowatt module, and technology is advancing to move them forward for design on new technology. You've got Stadler, Flirt H2, nice looking train there with an FC Wave 100 kilowatt. You got Siemens Muro, the Scottish hydrogen train project, again using 100 kilowatt in the Sierra Northern FC Wave. So there's lots of options out there in the rail option across Ballard's project. So I just want to talk about the Clean Ports program here. And, you've got almost $2.8 billion in US federal funding for zero emission equipment and infrastructure at wet and dry ports. You got eligible applicants include port authorities, air pollution control agencies, private entities owning and operating port facilities. There's so much activity taking place at ports, and they align really nicely with the federal government's initiative of the Clean City initiatives as well. That whole climate action plan pulling itself together and working with ports right across that whole value chain within regional government, and the project in 3 tiers: Tier A for 150 million to 500 million, and Tier B for 10 million to 140 million, and Tier C for strategically just for tribal applicants only, allowing for 2 to 50 million. And the EPA share of project cost is 80% across Tier A and 100% for Tier C. Then you've got hydrogen fuel cell, and hydrogen infrastructure is applicable. So lots of opportunity to develop innovative projects and strategies, and the application is due May 28th. So you got a couple weeks coming up where that application's due. So it's eligible for zero emission mobile equipment that serves a port. So thinking, of cargo handling equipment, terminal tractors, forklifts, fork handlers, side pickers, saddler carriers, it's all possible. Drayage trucks, locomotives, and rail car movers, harbor craft, and other vessels, even emergency response vehicles, as the need grows for emergency response vehicles across climate change challenges, and just emergency response right in general is increasing. So it's great to look at zero emission options there, and eligible zero emission infrastructure serving mobile port equipment. So looking at where that stationary power opportunity exists for shore power for marine vessels, electric charging and hydrogen fueling infrastructure, and solar and wind generation systems that are installed to be the primary power for mobile equipment. So Tim's going to walk us through here a little bit more about what possible projects could look like or ideas. It's all idea sharing and concepts, but Tim is here to take it away, and he's going to talk about port deployments and concept examples. Tim, it's up to you.
Yeah, thanks, Kim. Thanks for the great overview of Ballard products and projects. My name is Tim Sassine. I'm Director of Market Development and Public Affairs for Ballard for North America. I've been with Ballard since 2000, working in engineering and field service and commercial, and that's been a tremendous evolution of the entire industry, really getting ready for this commercial level that we need to attain for ports. The EPA port grant that Kim was talking about really is looking for equipment that's ready to go on the road. This is not R&D, this is deployment. So all those products and projects that Kim was talking about, those are all applicable to this EPA grant. And there's more funding coming down the road that we're seeing at the ports. As folks that we've invited to this webinar know, the ports are an incredible intersection of not only different transportation modes, but energy. It's a very intensive energy operation to transfer goods and cargoes between these modes. And so we have focused on the ports to get ready to help folks to get into the ports and to deploy in projects that make an impact. And I'm going to talk first about some of the projects that we have done already, and also some of the concepts that we look to see coming in the very near future. In Europe, they've got a head start already. Here's one at the port of Esbjerg, excuse my pronunciation, my Danish friends, but this is for a shore power application. So they've got 6 of our 100 kilowatt FC velocity modules that they've put together into a power generator that can provide power for vessels at berth so that they don't have to run their main engines and create the kind of emissions that are easily avoided when they just need to run their auxiliary systems. In the next slide, we see another example in Europe, this one at the Port of Valencia in Spain. This is another yard tractor implementation using Ballard fuel cells, this one with a 70 kilowatt fuel cell module, a little bit lower in power, but capable of doing the full duty cycle of a full shift. This one carrying about 12 kilograms of hydrogen compared to the 9 kilograms on the North American project, but capable of completing what they needed in their operations. And what we found also at the US operation was that if you can get that refueling time down to what we're seeing on transit buses, these things are capable of multi-shift operation, particularly when you look at wet hosing options that we'll talk about here in a minute as well. On the next slide, the trucks go on road. We're working on a project for Class 8 drayage trucks in British Columbia at the Port of Vancouver. This one is working with our partners at Hexagon Purus. And we're making a truck that is capable of doing the drayage operations. It's important in drayage that you don't pay for more than what you need. And in this case, we're using a couple of 100 kilowatt fuel cell modules to provide the power along with a battery pack and along with hydrogen storage to get to the operating power and the duration and range that they need to complete those port operations. This is one of a few truck projects that are out now and the beginning of an evolution of larger truck projects that are coming down the line as we see our XD module coming online, which will be at ACT Expo this year, which we'll talk about a little bit. That's coming up in just a few weeks if you want to check that out. So that's what we've done so far. Between those projects and the projects that Kim was talking about at the ports, we're seeing those things go out in vehicle by vehicle, component by component examples. Now we're being called to pull these things together into complete projects on a larger scale, in the scale, in the mid-range of $50 to $150 million for those Tier C projects that the EPA is talking about. We've put together a few concept examples of things that can be done at the port and equipment that can be used at the port. One of those, which is kind of a surprise over the recent couple of years, is EV charging. We've had several manufacturers come to us looking to put together power charging equipment to charge up Class 8 trucks and over the heavy duty EV equipment where they're having trouble either getting service because the grid has not been built out, or they've got a long delay before they can get the grid service, or there's just not grid capacity. This also buys them time to get those trucks to comply with the regulations that are kicking in very fast while they're still working out what's going to happen with the grid and with charging options. This shows an example of a conceptual system that is all commercially available equipment. In this case, putting together some of our fuel cell modules with a commercial EV charging system and coupled up with mobile fueling options. There are several companies that are making trailers for you that you can carry around gaseous hydrogen in meaningful quantities for situations like this. When it's not charging vehicles, that same unit is capable of providing other services, such as power backup, such as peak shaving. Particularly when you're charging big EV loads, you can have some nasty power peaks, and those periods where they're forgiving, demand charges are going to subside. So having equipment that can help you to shave that peak, and also in a world that we see coming soon, where hydrogen prices finally start decreasing and electricity prices are challenged, the end user can make that choice for their energy source for the most economic, whether it's electricity or hydrogen, as we become a fully decarbonized energy system. In the next slide, we see another example of equipment that we look to see on the road, particularly in this interim period. As ports invest in this new energy infrastructure, it's important that it be flexible. We know there's been a lot of change in the advancement of vehicles, and as ports figure out how to move energy around, whether they're going electric or fuel cell or both, they need flexibility. We've seen a few different iterations of portable liquid fueling facilities, liquid fueling trailers that are capable of wet hosing equipment, particularly transit buses, but that's moving on now to trucks as well. This in particular is a concept that adds on the capability of charging EVs, which is not a big step. And now you're looking at an asset that can serve multiple functions for backup power generation, for fueling fuel cell vehicles, for charging battery electric vehicles. So no matter how you're expanding or what your progression plan is, you've got the flexibility to move around the yard and to get to those sites as you get more permanent fueling facilities, as you get more permanent charging facilities set up. We're excited to see these things coming on the road because it's going to enable an awful lot of development. In the next slide, we've put together some concepts for how these things would play out in a port deployment for an initial hydrogen infrastructure that can get you on your way to decarbonization. This example, I've got two examples here. This first one is at a port that does a lot of produce coming in from Central America and also a lot of automobiles. They have roll-on, roll-off vehicles visiting their ports. So we're applying hydrogen in this case to provide shore power for those ro-ro ships, as well as additional power, zero emission power for the refrigerated containers as they sit there while they await transfer to their next facility. In this case, it's a facility with weak grid power, and so they're expecting large expenses from upgrading that system if it can be upgraded to do that. So hydrogen gives them the ability to address that load more quickly. In this case, we're looking at distribution within the plant, and something like a $30 to $50 million project cost, so right into that tier B for the EPA funding, for example. That next slide, you just got a quick peek of, shows how this would be laid out, in this case with a centralized fueling depot and putting hydrogen piping distribution throughout the port. Hydrogen pipelines have been installed, particularly in industrial uses. So this is not unprecedented, and it could be the most effective way to move hydrogen for multiple loads throughout the port, as I'm showing here. On the next slide, we get a little more up close and personal. In this case, yard trucks, yard dogs, a fleet of yard dogs charged up from a mobile charging trailer powered by hydrogen or fueled, fuel cell electric yard trucks fueled by such a trailer. In the next slide, another load, in this case, the FC Wave Mega Block powering these transportation refrigeration units as they sit there awaiting for transfer. And in the next one, a larger iteration of shore power, this one multi-megawatt for powering up tankers or other vessels that require shore power to avoid emissions penalties. In the next slide, we've got another example for a different port. This one also includes tankers coming in as well as offloading container ships. We've applied shore power for the ro-ros that are coming in with the cars, as well as central liquid fueling once again as an effective method for bringing hydrogen into the port, and looking at yard trucks as well as emission containment devices, a new animal that is seeing some usage in California. The next slide shows how this would be laid out with central fueling shared between multiple terminal operators, which is a challenge to coordinate between the ports, but very useful exercise if it can be done to coordinate that infrastructure development, because they can use that same infrastructure with some of these mobile options that we're proposing around the port. In the next slide, we see the yard trucks once again, a fleet of those, EV and fuel cell electric, one or the other, afforded by hydrogen, as well as some shore power with that liquid fueling. This is a mock-up of the liquid fueling station at Orange County, actually, the transit agency in Southern California, easily applied to port applications. Next slide shows one of these emission containment barges. These are being deployed to capture the emissions directly from the smokestacks of these vessels so that they can run those engines while they're at berth, and it actually processes it through a barge that has all of the diesel emission mitigation equipment. Normally that's powered by a diesel generator. In this case, we'd be swapping it out with a fuel cell electric power source, 200 or 400 kilowatts, working on that project, hopefully right now. As well as shore power, once again, in the multi-megawatt range, with our stacks through some of our partners that we're working with to build these larger systems to provide the power that the ships are going to need at berth. And so, you know, there's a multitude of constellations are possible. This is just meant to illustrate how these things can work together. And if you coordinate your implementation and your progression of zero emission equipment, particularly with hydrogen, it can help to double value and take advantage of some of those assets in multiple streams, making it far more cost effective. Kim, why don't you tell us about what's coming?
So Ballard has a series of events and sponsorships that we have ongoing throughout the year, and we really, our big show is ACT Expo here in North America. We're going to be in booth 1821. That's May 21st to 23rd. I encourage everybody that's on the call, if they haven't been to ACT Expo, to go. We're going to have displays of our different fuel cells, and our Tim will be there for sure, and you can connect with him and talk to him about a future project. Then we've got Hydrogen Fuel Cell 2024 is taking place in Los Angeles, California. That's June 5th and 6th. We got Fuel Cell in that's in Vancouver, June 17th and 19th. It's at the International Expo and Conference Center. Really nice venue there, right on the water in Vancouver. And then I'm chairing the Hydrogen Business Council annual conference. It's a hybrid virtual. If you can't attend in person, it's going to be in Toronto, but you can also attend virtually, and that's October 17th and 18th. That's a really unique technical based education conference, and it is kind of nice to be able to put your feet up and attend virtually if you can't make it in person. So next slide, please. Again, we have, if anybody has any questions, if they want to type in any questions, we can address them. If we can answer them, we will. If not, we're going to get back to you. But I don't think there's any in there right now. So that would mean we did a really good job, Tim.
Yeah. No, feel free to reach out to Kim and myself
Yes,
at all times.
absolutely.
We'll record this webinar. We'll have the slide deck available for you. It'll have our contact information in it. We've got information on all of our products and all of the projects that we've been involved in. We very much would love to partner with everyone at the ports, everyone who's creating projects at the ports and overseeing them and making them happen. So there's a lot of great work to be done in a short amount of time to do it. The EPA grant funding opportunity is a huge one that's going to enable a lot of important work, but there's other stuff coming up over the horizon, including the hydrogen hubs, which are coming, which
Yes.
include a lot of port operations as well. So definitely stay in touch. Reach out to us when you need more information. If you want to find out about anything that's going on in hydrogen globally, particularly Kim specializing in ports or myself for more of the technical aspects of our products, and we're more than happy to help.
Absolutely. Reach out anytime and make sure you attend future webinars that we have. And this is going to be posted on YouTube. So check out the Ballard social media webpage as well. I encourage you to do that. That's going to be this will be posted if you want to refresh, or some of our other, if you want to learn about, fueling or transit, we have webinars available there as well on our website, and great resources on our website at www.ballard.com. I think I said an extra W. So 3Ws.ballard.com. And feel free to reach out to Tim or I anytime. But thank you.
Thanks, everyone.